Hello everyone, my name is Josh. I was a computer science teacher for a number of years. I also work for the exam boards where I mark lots and lots of papers, and I'm making a series of lessons so that it's going to help you with your A-level computer science studies. This is for the OCR specification. If you are doing Cambridge International or AQA, please watch those. Now, one of the areas which is really challenging is logic gates and Boolean algebra. Logic gates and Boolean algebra, we need to make sure that you understand what the different gates are that you need to know for your exam. We also need to understand the truth tables associated with these gates, and then the hard part, the different rules to do with our Boolean algebra, and also how to actually apply this so that we get for Boolean simplification. So we're going to go through these steps. I'm going to try and do it as quickly as possible because, make this as efficient as possible for you. So let's go for it. So the first gate that we need to know is the NOT gate. Now you will remember a lot of this from GCSE, but the thing that you will not know is the Boolean notation, which is what you are expected to know for the Boolean algebra. Now OCR has a slightly different Boolean algebra that it uses from AQA and Cambridge International. To do not A, you need to put a little, it looks like a fallen over L, okay, so a fallen over capital L, and like that. The truth table's here. I'd get all of this information down, I'd put it on a flashcard, and then you can study it. An AND gate, remember AND, have to remember what this one looks like. It's A, N, and then it's like the D on the end of it. Obviously it's a capital D. Now, again, the thing that you will not be familiar from GCSE, if you didn't do GCSE, get all of this information down, but the Boolean algebra that you won't be familiar with is this. And what it is, it's like an N. Okay, so that's how I remember it. It's like the A in A, it's like the N in AND. So that's how you write it, A and B, because those are the two inputs going in there, and that's the output. Or, the way that I remember the OR is because it curves in at the back. It's like you can write the O in the OR at the back. Now with this, it's the N from the AND gate is flipped over. So you just flip it over and it's like a V. Okay, so that's how you do A or B. And this is all of the information that you need for this one. For creating different logic circuits, so these kind of questions do come up. I'm going to give you a little tactic for it. If they've got logic circuits where they've got multiple gates, this is how I would do it. So you take in the inputs, and the truth table essentially is all of the possible inputs and what could be all of the possible outputs. So you've got 0 or AND 0 because it's going into an AND gate to start with. And then we've got an output of R, and this is perfect in the way that it's set up. Because what we're going to do is we're going to work with R. Do not try and do the whole thing. Split it up into different areas, and then what you do is you just go through the different sections. So here we've got 0 and 0. So the truth table for that is going to be 0. 0 and 1. So remember that's going to be 0. 1 and 0, 0, and then that's going to be a 1. Then we take the output here, and then it goes into a NOT gate. So it's just going to be reversed. So it's going to be 1, 1, 1, 0. And that is probably one of the most important things. In your truth tables, you need to put different sections for the different AND gates, for all of the different OR gates, NOT gates, and then split it up and treat them individually, and then you get to the end of it. Don't try and do it all at once. So with all of that, that is then going to take us to a situation where, we can start creating them together, and then we've got the Boolean notation for it down here. So we've got A and B, and then all of that goes into an OR gate. But one of the things that we are going to want to do is have a quick look at the XOR gate, which is, with the XOR gate, this is one of the gates which you probably won't be familiar from GCSE unless you've done the Cambridge International specification. With this, what's going to happen is it works in terms of exclusively OR. So with an OR gate, it's one or the other or both of them. Exclusively OR essentially works with 0 or 1, but not both at the same time. And the Boolean notation for this is the OR symbol, but a line underneath it. And that's what the XOR gate or XOR gate is how you do that one. Now, what we're going to do is, in a new section, is we're going to get down all of the rules for Boolean algebra and how to simplify this. To give you an idea of why that we use Boolean algebra and why this is different, is there was a person called De Morgan who came up with this concept of how to simplify logic circuits. And the idea behind this, of why we want to simplify this, is because if the logic gates or logic circuits are more simple, then it's going to be less manufacturing costs and they're going to work more efficiently. So those are the two main advantages, and that could be a little 2-mark question that you could get there. Now, with the first law, one of the first ones is that not A or B is equal to not A and not B. That will feel, if this is the first time you've looked at this, you're probably thinking to yourself, why is it that I need to know that? Now, in certain situations, it's going to be more beneficial for you to swap that into that. And then in certain situations, it's going to be more beneficial for you to go that into that. And this is just a truth table to prove that this actually does work. So as you can see, that you get the same output, even though you apply it completely different gates to it. And you can swap them. They're both interchangeable between each other. So that's something that we need to do, because in certain situations it might be beneficial to do this. Certain situations it's going to be beneficial to do this. Now, if we look at the second law, not A and B is equal to not A and B is equal to not A or B. So again, there's the truth tables underneath it, and you can use those interchangeably because certain situations it's going to be better for you to do those. Now, these are kind of I think there's 17 different rules, so there's a lot of them. And what you just need to do is you just need to practice these lots of times. I would just spend time, all it needs is 10 minutes, a couple of times a day for the next few days, where you just write them out, see if you can remember them. If you can't, the ones that you can't remember, cover them up, write them out again until you can remember them in your head. Now, with this one, so let's go through why these work and why they are doing it, because I think if you understand why, that makes things a little bit more easier for your brain to remember. So you've got X and 0. So if we think about how an AND gate works, both of them have to be 1, don't they, for us to get an output of 1. Now in this case, if we've got 1, 0, it doesn't matter whether that's a 1 or a 0, it will always output as 0. For this one here, it's X and 1. So whatever X is, if it's a 0, it's going to be 0. If it's a 1, it's going to be a 1. So it's just going to be X, so we can get rid of that 1 there. So again, we're trying to reduce the number of gates or number of inputs that we've got there to make the logic circuit more simplified. X and X. If X is 0, it's going to be 0. If X is 1, it's going to be 1. So it's got that there. X and not X is going to simplify to 0, because whatever X is, we're always going to create a situation where there is going to be 1 or a 0. Because if X is 1, then that's going to be 0. So we are never going to get a situation with 2 1s. So then that will always simplify to 0. Then we're going to go into the OR gate. So X or 0 is X. The reason for this is because if X is 1 or X is 0, that is just going to be whatever X is, because we only need 1 1 in an OR gate for it to be a 1 overall. So whatever X is going to be that. X or 1 is going to simplify to 1, because we've got a situation where there is 1 1. An OR gate only needs 1 1. So that's why that would simplify to a 1, because whatever X is just going to simplify to there. And then X or X is just going to simplify to X, because if it's a 0, it would go to a 0, or 1, it would simplify to a 1. X or not X, this would actually flip round, and this would be a 1 in comparison to the same situation in an AND gate, because we're always going to create a situation where there is at least 1 1. And with an OR gate, if we create a situation where there is at least 1 1, that's what's going to happen there. And then not X is the same as X. Now if we think about that, because the double not there, what that would do is that would reverse it twice, so it just gets you back to the initial value. So it would, if not X is 0, not X is 1, and then take the not off again, then that would be a 0 again. So it just takes you back to the start, so you can take the double not off. There's still 2 after this, because we've got the absorption rule as well. But commutative, essentially it just means that you can just swap them around. It doesn't really matter which way around it is. So X and Y is equal to Y and X. Which, that kind of makes sense. If we think about the laws of the way I see it, AND is almost like timesing and OR is adding. So if you think about it in that, 2 plus 3 is equal to 3 plus 2. So there's that in there. Associative, where essentially that's a similar sort of situation where if you've got x and then in brackets you've got y and z, can you see that we've swapped the x into there? Because the gates are the same, you can just swap them in. And then here you've got the ors, and then you can swap those in there. So as long as the gates are all the same, you can swap the letters in, and it might be more beneficial for you to swap those in that particular circumstance. Distributive is almost like expanding brackets. That's the way that I think about it. So if you look here, if you add a value on the outside of the brackets, what you would do is you do x times y, which will give you x times y, x times z gives you x times z, but you've got an OR gate in the middle. And this is like expanding double brackets. So as you can see here, you've got expanding double brackets, and you just go through each. X times w gives you x times w, x times z gives you x times z, and then so on, and then you times the y's. So those are the ways, little heuristics that you can use to help you with trying to work out what those are. Absorption rule, this is just pattern recognition. Pattern recognition is probably the easiest way to actually know this one. With this, what you've got is you've got x, or, and then if the gates are swapped around, so if it doesn't matter whether it's an and then an or an or then an and, or an and then an or, and you've got two values which are exactly the same, one on the outside of the brackets, one in the inside of the brackets, they simplify down to the one where you've got two of the values for. So you can see here that they simplify down to x. All I would say to make this easy for yourself is just learn that pattern that you're looking for. So the gates are different, and then different in the ways of and or don't include XOR in that one. So and or are going to be different. And then the other condition that you need as well is that they've got two inputs which are the same. So two x's or two y's or two whatever it is, and then it simplifies down to that. Okay. The last thing that we need to do, and this only comes with practice, is you will just do more of these questions, and you'll start to notice that they follow a particular trend. If I'm honest with you, in OCR they tend to use the Carnot maps, which I'm going to do a lesson about next week, how that all works. But essentially with these, what you need to do is you need to just look at the patterns at which we can use to simplify them. So can you see here we've obviously got A or B and then A or C in there. So we use the distributive rule, which is like expanding the bracket. So B times A gives us B times A, and then we've got B times C gives us that. Now here, if we relate it back to the absorption rule, we've got a situation where A or the gates are different, and then what happens is we've got two letters which are the same, so that can just simplify down just to A. And now as you can see, we've actually cut it down so that we've got less input, so the circuit is way more simplified. This was actually a question from, I think it was the 2021 November paper that I just wanted to show you the rough level at which it's required of you. So it just says simplify this expression, try and show that so that it doesn't show any negation. And it's a 2-mark question. It's not crazy hard, but I mean, obviously if it's the first time you've seen it, this will look quite alien, but let's just talk about the steps. So expand the bracket, think about it like that. So you've times in the not, so you've got a double not, and then you've got a double not on B. Now if we relate that to one of the rules that we've got, which the double not, can't we take that off to just equals x? Obviously we can just take them off, so it's just going to be A and A or B, sorry. So it's just about noticing those patterns, and as I said, I know that if this is the first time that you've seen it, this will be feeling a bit horrible, but just keep trying with it, keep doing lots of questions, and you will start to notice little patterns. The ones which I've seen quite a lot of, I'm just going to put some different examples on, and if you cannot find any more questions, obviously message me and I'll get some questions over to you. Even use these ones, so just try writing them one time, and then the next day, because your brain will probably have forgotten them, try writing them again, see if you can practice the steps in there. They seem to use the distributive rule quite a lot. So the distributive rule is that multiplying brackets. Is it a guarantee that they're going to use it? Well, no, because as you saw in the last question, they didn't use it, did they? But I just see that one come up quite a lot. And then they seem to always use they sometimes use the absorption rule. So it's about noticing those little trends and patterns that the examiners seem to pick. So yeah, here you can see that I've used the distributive rule to expand the brackets here, and then essentially what we've done here is we've got which this one may be a little bit more difficult to see. They've used rule 7, which is x or x is equal to x. Well, can you see here how they've done that? They've actually cut out one of the brackets, completely cut out one of the brackets there. So you've got x and y or x and y, and that's simplified actually down to x and y, because even though there's two values in there, they're still exactly the same. So you've just cut them down from 2 to 1. And then here's a couple more examples there that I just thought that you could practice with. Again, the way that I would practice with this is just write them down, have a look at them and be like, okay, yeah, they've used the distributive rule there. Here they've used rule 4. Here they've used rule 5. And then later on in the day, try and see if you can remember the steps and look at them and see which ones, see how far you can get with trying to remember it, and then try it the next day. That'd be how I'd revise that, people. Just do as many questions that your teachers give you. As I said, if you need some more questions, just message me and I'll sort it out for you. Okay? Best of luck. Let me know how it goes. Let me know if you need anything. If you want to sign up for free exam support, please click the link in the description. And remember to subscribe for more free content.